All right, folks. We're going to talk about percent problems today. Pretty easy thing. I need you to be quiet and quit talking. All right, we're talking about percent problems. And you may have been taught how to do percent problems a different way in another class, and that's fine. It doesn't bother me that you have. But I want to show you the way that I want it done, okay? And the way that can help you be able to do these problems correctly. And the way that you want to do that is setting up the percent problems as proportions. Percent over 100. All right, so the way it's going to work is your problems are going to be given to you in a question form a lot of times, and they'll say something like, what is, or let's better yet, what percent? Let's start with one like that. It's a little easier to do. What percent of 25 is 17? Okay, and the way that you want to set those up is use the is over of equals percent over 100 format. If you use that format, it makes these problems very, very easy to set up. And once you set them up as proportions, cross multiply and solve. It's just like what we did last week. So it's really easy to do. And so when you look at this problem, you've got is 17, so that's going to be the is part. So that's 17 of 25. That's the of part. That goes on the bottom. And they ask for what percent. What percent says, oh, well, that's x over 100. The percent is always going to go over 100. Doesn't matter if you're looking for the percent or if they give you a percent, it always goes over 100. And then you've got a proportion to solve that you just cross multiply. That's 25x equals 1700. And then you divide by 25. X is 25. That's a quarter into $17. Be 68 quarters and $17. 4 times 17. And that would be 68% as a final answer there. So cross multiplying and solving. It's always is over of. Shannon.
Do we have to write it out like that?
Yes. Yes. Because I see people that try to take shortcuts and they get them wrong every single year. So we're not going to take those, what we think are shortcuts. What number is 30% of 90? Okay, so when we look at that problem, we've got a percentage, so we know where that goes over what? Over 100. So it's 30 over 100. And then we have an of. So where does that go? Top or bottom of the other side? Bottom. Is over of. We don't know the is, but we know the of. Is over of equals percent over 100. That's how you know. It gave you the of, so we know that goes here. Gave you the percent, you know that goes over a 100. The only thing missing is the is. So what number is the is? What number is the x? That's what we don't know. We're gonna know 2 out of the 3. We're gonna know the percent, or the of, or the is. We're gonna know 2 of those 3 every time. So we always think is over of equals percent over 100. Then cross multiply. What's confusing about is over of equals percent over 100? It's always that. Is over of equals percent over 100. The percent always goes over 100. Is always goes on top. Of always goes on the bottom. This is the of. We don't know is the is. We have a percentage, so that has to go over 100. Anytime they give you a percentage, that has to go over 100. If they ask for the percentage, you know the x goes over 100. That's the way that's going to work every single time if you set them up correctly. So that would be 2,700. So divide by 100, yeah, and x would be 27. That's not a percentage, it's a number. It says what number. It doesn't say what percent, it says what number. That's how you're going to set that up. Every problem is going to be a little bit different based on the way the question is asked. Some are going to be the same. Like this might say, what percent of 136 is 51? Okay. What percent? So we're looking for a percent. So what goes over 100? X. We're looking for a percent. So we know it's X over 100. The other side is over of. Which part is the is? Is 51 of 136. If you look at it in that way, the problems are going to be asked like this. You got to think is over of equals percent over 100. Every time that proportion set up is going to be the same. Okay. And then cross multiply and divide. Yeah, we'll see some more examples of that. Yeah, in just a second. So, at 136x 5100. Do the division, and I'll go ahead and tell you the quiz that we're going to have over this. We're only going to have one. We're not going to have a calculator and non-calculator. I'm going to let you use a calculator on the only quiz that we'll have over percent problems. That doesn't mean that that's the way it's going to be from here on out. That's just on this quiz. That's how it is. So we're dividing 5100 by 136. 5100 divided by 136. 37 and a half. And that is a percentage because they asked for a percentage. What percent? So you're going to have that percent symbol. All right, so what number is 45% of 92? Equals, yeah, 45 over 100. Good job. What number is, we're looking for the is, we have the of, and a percentage. So we know 2 out of the 3. So we just set them up that way. Cross multiply. 100x, 92 times 45. 4140. Divide by 100. Dividing by 100 is easy. That just moves the decimal place twice. 41.4. And we don't need a percentage there because we're just looking for the number. 41.4 is the number. That is that. Let's look at another one. 75 is 150% of what number? There's no of, so what goes in its place? X. So of is on the bottom. It's got an X there. 75 is on the top. The other side is the percent side. 150 over 100. So it said 150%. So we know that 150 goes over 100. Whatever the percentage is, if they give you that, you know that has to go over 100. Start with that side. Make sure you got that side done. That makes the other side much easier because all you're looking for is an is or an of. Okay. Cross multiply. 150x equals 7,500. divide. Zeros cancel. 15 goes into 75. 5 times. 1 0 left over. 50. 75 is 150% of 50. Not a percentage there, just a number. Sure. Let's do this one. 65 is 62.5% of what number? Set up on this one. 65 over x. Good job. 62.5 over 100 and 65 over x. Cross multiply and divide. $6,500 divided by 62.5. 104. Not too bad. That JC, is that cleared up a little bit better? Make more sense now. I figured seeing a few more examples would get you on the right track for that. But this is what I want to see. I want to see the proportion set up, and then the work that's going on to get there. That's what I want to see as you're doing this this stuff. Let's look at some real world applications of this. This is one of the most easily applied to everyday life things that you'll do in an algebra class is percent problems. Let's say you had a bill was $15.75 at a restaurant, and you want to leave a tip. And let's say it's decent service, so 15% tip. How much is the total when we pay everything? Tip and all. Let's say we're swapping our debit card. We need to leave a tip. We want to leave a 15% tip. So what's the total? A couple of different ways to work this. And somebody set us up one of the ways. So for Shannon, go ahead. Okay. Yes, that's correct. Because we're leaving 15% of our total bill of our bill. Our bill is $15.75 right now. So we're going to tip off of that amount. And so we're going to have an X in the numerator there. So that's one way to do this problem. It's probably the most common way of doing that. That's going to find us what? It's going to find us our total bill. It'll just find us the tip amount, right? It won't find us our total bill. How would we take that and find our total bill? Add it to it. This is the most common way of doing that, is just finding that percentage and then going from there. So cross multiply 100x equals 15 times 15.75. So 15 times 15 and 3/4, 236.25. Divide by 100, and our tip is $2.36 and a little bit more. Okay, we can't tip a quarter of a penny. certain percent of this kind and a certain percent of that. Yeah. So what'd you do? Do the proportion like that? Yeah. Yeah, and it's one of those things that it's used in quite a few different areas. Mixing feed or percentage, a certain percent needs to be a protein, certain needs to be, the grass seed or whatever it is, depending on what you're doing, where you go from there. Here we found the tip amount there. Now here's you got to make a choice, ethically here, which way you go. Do you round up to 237 or you stay at 236? Yeah, mathematically you would stay at 236. I think me personally, I would go ahead and give them another penny, just because that's just me. But mathematically rounding, you're going to round mathematically since we're in a math class. So let's round it to the nearest cent would be 236. So we're going to take 1575 and add 236 to that. $18.11 is our total bill. $18.11 is our total. Now that's one way to do it. Another way to do that would be what percentage of 1575 are you really paying when you leave a 15% tip? Not just 15%. You're paying a total that's bigger than 15% or bigger than $15.75. So it's over 100%. So you could do this problem and instead of finding the $2.36, you could put this instead of 15 up here, you could put 115 up there, and that would get you the total bill at the very end with one problem instead of having to do the addition at the end. And that either way works fine. This is the most common way of doing that. That's why we did it that way. But there are other ways to do that, and that would be to change that to 15. That 15% to 115% would be one way to do that. Let's say this is what happens. Your bill is $12.43, and you pay $15 in cash, and tell the waitress or waiter, whichever one you want to put there, to keep the change. What percent or percentage was your tip? Okay. So this is pretty common practice that you go somewhere, your bill was $12.43, and instead of calculating a tip, you decide, okay, I got a $10 bill and a $5 bill. I'm going to give them that and say keep the change, and you get the tip for the rest of it. What percent did you really give them as a tip? So how could we figure that out? Okay. 15 minus 1243, that finds you what? How much the difference is, what the tip was. So that's the is, how much is the tip? Remember our total bill was 1243. So that's the of. Is 15 minus 1243 over of. We're looking for what? Percentage. So that'd be x over 100. So what's $15 minus $12.43? $2.57. Cross multiply. 1243x equals 257. 100 times 257. Divide. And again, we're using a calculator today because we're dealing with dollars and cents here. So 257, 1243, 20.68%. A 20.68% tip. That would be on the higher end of tipping. Low end is 10%, higher end is around 20% if you're by etiquette there. So tips do what to your bill? Make it bigger. Discounts do what to your bill? Make it smaller. So let's look at a discount problem. This is a pretty common thing. Most of us do this, or we should be doing this if we're shopping. The shirt is marked $19 and is on sale for 20% off. What is the sale price? All right. A couple of different ways to do this. Both valid ways of doing this and common practice in doing this. Okay, so what's one way to do this? Well, 20 over 100 is equal to what? $19 is the original price, right? So we're looking for taking 20% off of that. So X over 19 would be the setup for that. And we could cross multiply the 38 and a 0, so 380. Divide by 100, that makes the math easy. $3.80. That's the sale price. That's how much you take off of it. So we've got to then do the $19 minus $3.80. I know that's 20 cents. Be $15.20. Okay. Now here's how I do that if I'm in the store. And I'm looking at that, and they don't have one of those little price checker things. You can go and scan the barcode and see how much it's really going to cost when you go to the register. They don't have one of those in the store. So I'm thinking, okay, 20%, a little harder to do than 10%. 10% is really easy to figure. You just move the decimal place once. The $1.90 is 10%. 20% is how many 10%? Two of them, right? 20% is 10% twice. $1.90 plus $1.90, $3.80. I know I'm getting $3.80 off. So that's around $4 off. So I'm getting the shirt for around $15. So that's how I kind of do that when I'm in the store shopping. My wife is really good at this. She's a math teacher too, so that really does. It's not fair, but we that's how we do things. Another way to set this up, where the proportion would give you the actual sale price, would be instead of putting 20% here, what could you put? Because that would make our price bigger. Remember, we want the price to be smaller than $19. So if we're getting 20% off, how much are we really? What percentage are we really paying? 80%. So we could put 80 over 100 there, and then when we cross multiply, we would actually get we would actually get the sale price by doing it that way. And that's a pretty common practice to do it that way too. This was the most common way for us. Well, it was $19 to start with. We almost got $4 off of it. It's not a big sale. 50% off, yeah, that's you're going to get it for half of that. So that 20% off is not a big sale. 30% is a little bigger discount. 50% is a really big discount. 75%, they're giving it away. It's a yard sale. prices kind of stuff. So, but 20% off is pretty good. My wife says this is not a good example because you can't buy a girl's shirt for $19 or a lady's blouse or something for $19. She says they cost more than that. They're marked up real high, and then they act like they're giving you a deal. So, all right. So setting up those proportions and solving them, those are percent problems. That's our goal. So today we're going to practice that a little bit. And then here's the plan of attack is tomorrow we'll come in, we'll answer questions at the beginning of the period, do a few more problems together, and then we'll quiz over percent problems tomorrow and before we leave here, okay? So on page 179, 3 through 29, 33, 34, 35, we're going to do all of them on that page. But we're going to quiz tomorrow over percent problems. So we're not taking a whole week to learn how to do percent problems. You got to get it today and in questions tomorrow. So make sure you're working today, getting this stuff down. And then we're going to move on to solving equations for a particular variable after that. Shannon.